And here we go. We have liftoff. Propulsion continues to be normal.
R68 chamber pressure looks good.
Following up. Roger, roll, Atlantis.
Water towers fly! Yes!
Tango down to nominal.
Flight downside FD off. Bring in FD off. It's orange!
145! Oh my god!
Decollage.
Look at this!
Put that in the big bag, Eagle.
343 unfolds to go.
Indeed.
We rise together, back to the moon and beyond.
The methane will be igniting in the flare, correct?
Yikes. You read? We don't need any more of these.
All right, folks, you know the drill. It is time for another Intrepid Museum Astro Live. Let me know over in the chat, whichever chat you're on, because this is going out on quite a few channels today. If you can see and hear me, my name is John Galloway with NSF, and I'll look over at the chat, it's this way, to see if y'all are giving me some 5x5s, indicating that all the lights are blinking in the proper order. Are they? I see some 5x5s already. Well done. I appreciate the help with the remote production there. You know what we do with the Intrepid Museum shows? We try to get together. We get scientists, engineers, folks who have information that's interesting to listen to, folks who have stories and tales and cool designs and problems that they solved and all that sort of stuff, right? We've got a real treat for you today with some underwater salvage operations for spacecraft. But first, a little bit of housekeeping. You know the drill. The Astro Lives don't just happen. They don't just magically appear out of the ether. They happen because you all show up to watch them, but they also happen through the support of a NASA cooperative agreement awarded to the New York Space Grant Consortium. Also, if you scroll down a little bit on the YouTube channels, you'll see that we are doing this fundraiser today for Intrepid Museum's virtual programming. You can support the museum's virtual educational programming by clicking down, and there is that donate button below to help these shows going. I don't know if y'all see the total. I see the total is like $55 shy of $4,000 that y'all have put together to help support these sorts of programmings, because you think it's important to share this sort of content with folks out there around the world. Over the course of the show today, ask us some questions, tag us in whichever chat you're watching on, at NASA Spaceflight or at NSF, if you are on the NSF channel, or at whatever other channel you're watching. I think we're on NSF's Facebook as well today. Just trying to get the word as far and wide as possible. But here's the deal for today's show. Recovering spacecraft, right? It's not always been as easy as it is these days. You don't just land the rocket on a barge and it's just so convenient. You just float the barge back in and now there's your parts, right? Sometimes in the past, you've had to go out there and get spacecraft. Sometimes they came in on aircraft carriers. Sometimes they ended up on the bottom of the ocean. And we have an expert with us today who was actually involved heavily in the recovery of the Liberty Bell 7. Which was back in the Mercury program, one of the original space flights, the suborbital space flights we did. Also involved with multiple air disaster recoveries and the recovery of the Challenger. So that's our guest today, right? We're going to get him the microphone. We're going to let him tell you about his experience, tell you some of the things that he has seen and heard and done out there on the waters, recovering these things. To set the stage for us first, we've got Alicia Seagull with Intrepid Museum. Alicia, how you doing today?
Hello, I'm doing just great. So excited to be here today, of course, for another Astro Live. And yeah, if you've been watching our Astro Lives recently, you might have noticed that we have a bit of a theme going on. We keep diving, into this overlap between space exploration and the deep sea. And there is actually a reason for all of that, of course. Back in June, the Intrepid Museum opened a brand new exhibit called Mysteries from the Deep, Exploring Underwater Archaeology, which is right inside of our Space Shuttle Pavilion, as you can see behind me. And it's right under the Enterprise. I'll talk a little bit more about the exhibit with you later in the show, but ever since it's opened, we've actually been spotlighting a lot of the fascinating ways that these two worlds intersect. So you might have noticed earlier this summer, we did an epic tour of NASA's Neutral Buoyancy Lab, where where all the astronauts train for their spacewalks. We took a closer look at how spacesuits and exosuits can protect people in those harsh environments. Last month, we actually talked to 2 deep sea explorers who accidentally came across a piece of the Space Shuttle Challenger when they were just happened to be looking for something else completely different, a lost squadron of World War II planes near the Bermuda Triangle. And today we have another amazing space-related underwater recovery story. And it is about arguably, I think, one of the most famous incidents of a space vehicle being lost at sea. And we're not talking, of course, about a Starship test flight or a sad instance of a Falcon 9 booster falling off of a drone ship or something. Oh, they were so sad though, right? We are, of course, talking about Gus Grissom's Mercury capsule, the Liberty Bell 7. And the Intrepid has a really neat connection to Gus Grissom as well. Well, so first of all, July 21st, 1961, right? Gus Grissom launches. He was on the second crewed Mercury mission. The flight itself went very smoothly. But after he splashed back down into the Atlantic and was waiting to be recovered, the capsule's explosive side hatch, it unexpectedly blew open, let in a bunch of water, and the capsule started to sink. So Grissom managed to get out, but his suit started filling up with water. Here's some footage actually from NASA from that experience. So the helicopter comes to try to lift it out of the water, but it's too heavy now, right? It's all flooded. So they have to cut it loose, and it ended up being lost 3 miles down to the bottom of the ocean.
Wow.
So I mentioned, of course, Intrepid has a funny history related to Gus Grissom too. I have to mention this, of course, working here. So we actually picked up, the Intrepid did, we picked up the Gemini III capsule that he later flew in with John Young a few years later in 1965. And the funny story connecting us to that one is that at the time, the astronauts were allowed to name their capsules. So for Gemini, Gus Grissom actually at the time got inspired by the name of a Broadway musical at the time, which was called The Unsinkable Molly Brown. And you can maybe see where I'm going with this. So he had been accused of being a little sensitive about this particular Mercury capsule being lost. And so he and John Young thought it would be funny to name their Gemini capsule Molly Brown. Of course, NASA wasn't too amused by that. And they were like, all right, well, give us a backup option. And he goes, oh, well, how about the Titanic? So Molly Brown it was. So
they chose the lesser of the easier of the 2 options, I guess, huh?
That's right. Yeah. They weren't too thrilled to be talking about that story because it wasn't a great thing at the time that happened. But there is a lot of debate now in the space community. It has been for years over what happened with that hatch. Like, why did that fire? Did he accidentally trigger it? Was there a mechanical or electrical issue or static electricity? What was it? A lot of speculation, a lot of analysis. And so today, I will shut up and we'll bring on our guest. We are going to be talking a bit about that story with someone who actually helped to bring this historic spacecraft back to the surface after almost 40 years. So yeah, I think we should bring him on. What do you think?
I think that sounds good. Let's get Curt over here.
Amazing. So this is Curt Newport, everyone. He develops and operates underwater technologies. He's worked in commercial and government underwater operations for almost 50 years and has quite a storied history. He's participated in over 150 deep sea operations around the world, including the salvage of the Space Shuttle Challenger, the TWA 800. He broadcast live images from the Titanic, the search for the flight MH370, as well as many other classified missions involving the loss of military aircraft and weaponry, and of course led the expedition to locate and recover Liberty Bell 7, the Mercury spacecraft, which also remains to this day the deepest commercial salvage operation in history. So congratulations on that, and welcome to the show, Curt.
Thank you. Thank you very much. I'm happy to be here.
Amazing. So, yeah, I mean, I'm just curious, what drew you to this story here? Like, were you familiar with the sinking already, or did someone reach out to you and say, hey, you've done a lot of experience. Come, you've had a lot of experience doing this stuff. Come and help us with this topic.
No, actually, part of what it came down to is I lived in St. Louis when Grissom flew. And, back at that time in 1961, Project Mercury was a very big deal. And I remember Alan Shepard's flight more, riding my bicycle around in my school parking lot. But I also knew about Grissom, and I guess I must have remembered that the spacecraft was lost. And then after I've been working in the subsea profession for about 10 years, this would have been 85. You work with all this technology. And most of what I had been doing at that point in time was oil field work, doing inspections of oil rigs, and I'd started doing some submarine cable work. And I just thought, well, what would be a fun project to do? I mean, what would be interesting and historic? And of course, I remember that Liberty Bell 7 had been lost and had never been recovered. And I just basically started researching it to find out, well, is it possible that it could be found? I mean, what type of information is available, defining where it sank and where it ended up? When I first started the research, I just looked at a few books, and there was typically just a cursory mention of the fact of what happened. The spacecraft sank, and various descriptions of where it sank. And so it really just started from there. I mean, I just started researching it kind of as a hobby. And let's see, I guess what really made me think that it was possible to do that was the Air India Flight 182 salvage. We were in a lot shallower water, about 6,200 feet. But the techniques we were using with these Kevlar recovery lines, I just came to the conclusion that, if you could find that spacecraft, then you could definitely be recovered. You just have to attach a line to it and pull it up. Of course, there's a whole lot of other issues with that, because finding it is not a trivial task. It's a very small object. It's in deep water. And then the ultimate question is, well, how are you going to pay for all that? And I was kind of naive at the time about the fundraising aspects of the expedition, and figured, well, if you can prove that it can be done, of course someone will pay for it. And that turned out not to be true. I mean, it was ultimately, but it was, it could have been done really in the late 80s or early 90s, but I couldn't find anyone to pay for it.
No kidding.
And ultimately, things like this, a lot of it comes down to timing. And that's how it kind of worked out with the Discovery Channel.
Yeah, this is the type of people we like to hang out with on the show. You're like, oh, I need a fun and interesting project. Let's recover a historic spacecraft from 3 miles underwater. That sounds like fun. That's your area of expertise. That's like what you do, right, Kurt?
Yeah, at the time, I didn't really have a lot of experience in deep ocean search operations. In fact, I don't think there had ever been a search operation in that water depth. But, I knew the technology. I kind of knew what was out there. And I figured, well, if it can't be done now, it's not going to be too long before you can do it. But eventually, technology evolved. And even now, I mean, if we were going to go out and try to do something like this right now, it wouldn't be done the same way. We wouldn't use a towed sonar. We would probably use an autonomous underwater vehicle. And the types of imaging sonars that are out there now are better than what we had in 1999. But what we had in 1999, the Ocean Explorer 6000 was obviously good enough, and found the spacecraft. And from there, it just came down to a matter of interpreting the records and trying to figure out exactly which target was the spacecraft.
How does that work? Like you're scanning the ocean floor, right? You're in a ship up on the surface. Are you driving a grid pattern back and forth across the ocean with a sensor towing, trying to get pings off of something? Like, what does the map look like? How do you know that you're looking at a spacecraft and not a rock or something?
Well, with the type of sonar we had back then, it was a AMS style sonar. I can't even remember what that stands for. It was low frequency. Didn't have terribly good resolution, but it was really good at finding stuff. It had a lot of power. It put a lot of acoustic energy into the water. And really what it comes down to, a lot of us just experience. Myself at that time, I didn't personally have a lot of experience with side scan sonar operations. I'd used a lot of sonars on underwater vehicles. But towing a side scan is different. And the thing people have to remember, when you're towing a sonar like that, like we're in 4,800 meters of water, well, it takes a lot of cable to get that sonar down the depth. And once you have it at depth, to find something that small, you have to go very slowly. During this operation, our target towing speed was only 1.5 knots. And
wow.
So you do like a grid pattern. This I think we were operating on the 1 kilometer swath, which means we were looking at 500 meters on each side of the sonar, towing at 1.5 knots, But the thing is, when you have that much cable in the water, our search lines were 8 miles long, 8 nautical miles long. The
Wow.
search box was 3 by 8 miles, which is smaller than I wanted, but that's what we could afford. And but once you get done with the search line, and you figure 8 mile long search line, it takes a few hours just to do the search line. When you get done with the line, you have to do a turn. You have to turn the ship around with all of this cable out and reposition it to go back in the other direction. And that could take anywhere from 8 to 12 hours just to turn the ship.
Wow.
Because you have so much cable out. So typically what we would do is once we got done with the line, we were at what's called EOL or end of line. We would haul a lot of the cable back in because it made it easier to turn the ship. And then we would do what's called a Williamson turn, where we would do a special pattern, turn back around. And then once we got established back on the line again, we'd pay all that cable out again and then do the next search line. And the other thing was that because this was such a small target, the capsule is only about 6 feet in diameter and 9 feet tall.
Yep.
If you towed the sonar directly over the top of the capsule, you may not see it. And so we had to do lines in between the other lines, fill-in lines to make sure we could see the target. See,
Overlap.
Oh yeah, is the audience seeing this picture?
Yeah, they are.
Okay, that is actually my plotting chart from the expedition. And the reason it's always different symbols, you have red triangles, then you have some squares and circles, and all of these little data boxes identify a geographic location. And within that data box, I established where the position came from, whether it was a written or a numerical position, just so I could get an idea of what was what. And all those little triangles and circles are actually sonar contacts.
Right.
And the reason they're all different shapes is because I wanted to be able to look at the chart and be able to figure out, well, what are the really good targets? What are the targets that maybe aren't so good? So the red triangular contacts are singular hard targets, which is what we were looking for. And if you look over in the upper left-hand corner, you can see a red triangle. It says 71. So
Yep.
hard target on ravine. That was a spacecraft. And if you look in the center, in the center of the chart, you can see there are like these 3 little dots, and there's like little dotted lines going up to the northwest. And what that is the most accurate position I felt existed on the spacecraft was from a tracking radar that was on Grand Bahama Island. It was called the FPS-16 precision tracking radar.
Right.
And in the automatic beacon mode, with the C and S band beacons on the spacecraft, it was really accurate. The problem was it only tracked the spacecraft down to an altitude of 11,000 feet. And at that time, the capsule went below the radar horizon. So what I did was I got the winds aloft data from Grand Bahama Island and put in drift lines saying, okay, if it was here when the radar last had it, it probably drifted about a 1.3 nautical miles to the northwest.
Right.
And that wind corrected location was my best guess of where the spacecraft actually landed. And as it turned out, I think it was about a mile to the west of where I thought it was. The latitude was pretty good, but it was about a mile to the west.
Can we move this graphic up so the 71 is sort of in the center? I think I can explain what you're talking about here. I see the 71 labeled hard target on ravine. Perfect.
Right.
And then these, right there. These lines in here, are these the lines sort of going to the northwest that was your drift guess?
Yes.
Yeah. And you have the greens down here. Is this the radar contact? And then you calculated, it might be around here because of like if it were to drift with the known winds at the time, it would go from the greens to the reds or pinks there?
Yeah, basically the ones at the bottom there would have been, this is where it would have been before they lost tracking. And because of the prevailing winds at the time, it would have gone to the northwest. And so I corrected all of those positions. And there was a lot of different ways that they tracked this spacecraft during the flight. I mean, they had something called IP7090, that's impact position 7090, and I had to learn all this stuff. See, I didn't know anything really about how NASA tracked spacecraft in 1961. I had to kind of teach myself about it so I could better understand, well, what are the really good locations and what are the ones that maybe aren't so good? And the IP 7090 stands for the 7090 mainframe computers, the IBM computers that they had at the Goddard Space Flight
Yeah.
Center that did real-time tracking in the capsule. But that wasn't the only location. There were multiple locations of where this spacecraft was said to have landed. There was a location from the carrier, the USS Randolph, which was a Loran Alpha location. That's a form of long-range radio navigation. Then there was what's called a SOFAR bomb location, which stands for sound fixing and ranging. And that was from the pyrotechnic device that was jettisoned by the spacecraft when the main parachutes came out.
Yeah, there's the
always,
SOFAR bomb down there, right?
Yeah, so there's
Yeah.
all these different locations, and you really got to kind of figure out, well, which one's the best? Which one will most likely indicate where the spacecraft sank? And I really like that radar location because I had some good information on how accurate those radars were.
Yep.
And it got it down to 11,000 foot altitude. And I figured, well, the wind data was pretty good. And, it was just my best guess of where we should look for this thing.
Yeah. Another thing I think people don't understand is nowadays I can look at my portable pocket computer and it talks to satellites and it tells me within a couple feet about where I am. Well, when this capsule splashed down, GPS wasn't a thing. The space program was just getting going and we didn't have a network of GPS satellites that even the big military ships wouldn't talk to the satellites and say exactly where they were. So it's not like this helicopter that went to recover the capsule had an exact GPS fix. This is before GPS. So You're looking at the radar and the winds. Yeah, here you go. This helicopter has no clue. Well, it's not talking to satellites, I guess, to figure out where it is.
Well, you can see this is Jim Lewis's helicopter. You can see the aircraft carrier in the background. And what's funny is, the aircraft carrier location, it would have been a general area. It's like, okay, we're going to go into this general area because they did their navigation by Loran Alpha.
Yeah.
And then they also actually did celestial navigation with a sextant. And what's interesting is Jim Lewis told me that he had a TACAN in the helicopters that stands for, I think it's tactical radio navigation or something, which would have given him an exact range and bearing to the helicopter, but he hit to the aircraft carrier, but he didn't have it turned on. I guess he didn't feel it was necessary because he could see the aircraft carrier.
Yeah.
I mean, he knew where it was.
It also wasn't supposed to sink.
Well, yeah, there's that too.
Yeah.
But you're right. In 1961, you didn't have any of the GPS satellites or any of that stuff. And the other thing was, and this is something I had to figure out on my own, was that, okay, when you do navigation, I'm trying to think of how to say this because I'm not even sure I totally understand it myself. Navigation is defined by an ellipsoid, and that sort of defines like what the shape of the planet is. Well, in 1961, when NASA was doing these flights, they used what's called a Clark 1888 ellipsoid, and that's just the way they determined where everything was on the Earth.
Right.
But when we navigate now, we use what's called WGS 84. That ellipsoid, which stands for World Geodetic System, and was made in 1984. Well, the difference between those two ellipsoids in that area is about 500 meters.
Right.
So basically, when we first went out to search for for the spacecraft, we were navigating in the same ellipsoid NASA used in 1961 when they did the flight. In fact, before we even left for the expedition, we actually went to the very launch pad that Grissom took from and took an updated GPS fix on it to make sure that we knew exactly where it was. Because one of the ways we were identifying where we were searching was the range and bearing from the launch pad. And the launch pad was surveyed in by the Army Corps of Engineers, and they did a pretty good job. It was only off by like 30 feet. So we really did everything we could to like take out any possible error. But
yeah,
this navigation thing with the ellipsoids, that came back to haunt us when we actually went and did the recovery. And I'll talk about that later, or I can talk about it now.
Whenever you want to talk about it.
Well, when we went out to originally search for the spacecraft, we were navigated in the Clark ellipsoid, which is what NASA used in 61. Well, after we lost the Magellan ROV, I mean the Magellan 725 ROV, we came back in, regrouped, got a new vehicle. We went back out. The company doing the navigation for us, well, they sent 2 new navigators. They weren't the same guys. And when they went out, they were navigating in WGS 84, which was the wrong ellipsoid. So when we went back out, I had 3 days in our budget that I wanted to spend looking for that explosive hatch.
Right.
And I had several targets within 1.5 miles of where we found the capsule. And I really thought one of those would be the hatch. The unfortunate part is, because of the fact that they were navigating us in the wrong ellipsoid, we were off by 500 meters, and it took us almost 3 days just to find the spacecraft again.
Wow.
And that burned up all of our time.
Your
that I
time and
wanted
budget.
that I wanted to spend looking for the hatch.
Yep.
So, you are running into these issues in, that year, right? Like in the 90s. I'm curious too, like, why do you think NASA didn't try to, this is new technology, right? This explosive hatch, and trying to figure out what happened, I feel like is probably very important, because this is such an early phase of the space, just the whole space program here, trying to make sure that people are going to be safe up there. Why do you think they didn't try to retrieve the capsule earlier, or find that hatch to be able to discern all of this stuff? Do you think it was just that they didn't have the technology to do everything you were doing, at that point?
No, that kind of capability did not exist in 1961. At the time, no one had ever done a search in that kind of water depth, an underwater search. There wasn't side scan sonars, did not even exist. And even if they knew exactly where the spacecraft was, the only vehicle they had to dive to that depth was the Trieste, and it's a huge bathyscaphe. It's rated that's the vehicle that did the deep dives in the Challenger Deep off of Guam back in, I guess it was 1960 or 59. It was wholly unsuited to doing an operation like this. So no, that they had no way to go find it and recover it. And what's funny is when they were out there on the carrier, I think it was one of the reporters or someone, I know it was somebody from NASA asked the captain, H.E. Cook, he said, well, gee, the spacecraft sank. Shouldn't we like put a marker in the water, like a smoke bomb or something? And he said, well, it's a little too deep for that. So
yeah,
they didn't even bother.
I've got a quick question on the image we're looking at here, this Magellan 725. This sort of gantry, for lack of a better term, up here in the corner, are those cameras and lights?
Yeah. Yeah, there's okay, that's actually very similar to the lighting rig that we use when we broadcast live images from the Titanic.
Right.
If you look at that horizontal boom, on both the far end and the nearest end are 2 HMI lights. Those are very special underwater lights that have put out light. I think the wavelength's about 6,000 Kelvin, and they're really great. And then the other 2 items in the middle are cameras.
Right.
I thought we only had one camera. Well, we had one of the cameras was a high resolution camera developed by Woods Hole Oceanographic Institute, and basically and it's in a titanium housing. It's really expensive.
Yep.
And what they did was they took a Sony Betacam and basically took it to bits and put it inside of an underwater housing.
They deconstructed a Betacam to make it fit. It's a tube. It's interesting. We see housings like this around Starship rocket launches, some similar tube type of housings, but a Betacam they took apart. Sorry.
Yeah. Apparently they modified it and managed to stick it inside the titanium housing. That would be the camera on the far side. The one in the middle, I just can't remember what that might just be a standard underwater camera. And they put this whole platform in the front of the vehicle so that you had someplace to mount the cameras. And what you can't see in this picture, there's actually a very large electronics bottle on the rear of the vehicle that actually sticks out from the rear of the vehicle.
Right.
So it was a lot of stuff I have to have on that size ROV.
Yeah.
And the vehicle is, it doesn't have much horsepower. It's only a 25 horsepower vehicle.
Oh, wow.
The 725 comes from, the vehicle is rated to 7,000 meters, and it has 25 horsepower. Yeah, if you look in that picture, you can see that thing sticking out of the rear of the vehicle.
That?
Yeah, that's the electronics housing for the cameras that are
for
on
the
the front.
cameras to balance it out, I guess, like the center of mass, huh?
No, it's not to balance it out.
It's not?
You needed the electronics in the aft housing to run the cameras because that's where the optical fiber interface was.
Ah,
Because the the umbilical that goes to that vehicle, it's optical fiber down to this thing called the depressor, which is in the lower left corner of that picture.
right.
So the way it works is you lower that depressor down, and then the vehicle flies around the depressor on a soft tether. Well, it's only optical fiber or down to this depressor, and then when it goes from the depressor to the vehicle, it's just copper wiring.
Ah,
Well, we still got really nice imagery on the bottom, and the thing on the right side of the picture that's the manipulator is holding is actually part of a plastic deck chair, and they use that to set the white balance on the camera when we were underwater.
really?
Yeah.
This part right here, I guess it looks like somebody took the back off of a chair and they just strapped it to the manipulator.
That's exactly what it is. It's the back of a plastic chair, and it's got a little weight on it, and they would stick it on the bottom, back off, and then adjust the white balance on the camera.
Very practical.
It's very practical.
Also, if you look at there's a line coming from the underneath of the vehicle going down, and you can't really see what it is in that picture.
Yep.
That is a large clump of chain. And what that was, it's a descent weight. And it makes it so when you put the vehicle in the water, it sinks faster. And that way you waste less time getting to the bottom. And then when you get to the bottom, there's a hydraulic release for that line, and then you just drop the descent weight, then you can maneuver, normally.
So it just makes it sink faster, so you don't spend forever for it going 3 miles deep, and then you don't need it whenever you're moving around or come back up.
Well, even with that, it's still gonna take 3 to 4 hours to get to the bottom.
Wow.
And that's a very common technique to use. Most autonomous vehicles do the same thing. When we were searching for the Indianapolis with the Vulcan's Remus 6000 vehicle, it also had a big chunk of chain, and they would just put the vehicle in the water. It just sink like a stone. And when it got to about, I think, there we go. That's the Remus right there. When we got to about, I think it was 100 meters off the bottom, it would release the descent weight, and then the vehicle could start its mission.
Huh. Just do its operations. Did I hear you correctly? It like, for lack of a better term, set down a base station, and then the ROV would move around the base station? Did I understand that correctly?
It's really not a base station. It's a depressor. It's a depressor.
Depressor.
And what that does is, it does a couple of things. First of all, it converts the optical fiber video data to just normal electrical video,
right, on the copper,
which goes to the vehicle. And the other thing is, that's where all the transformers are, because to operate a vehicle at that depth, you're typically sending down anywhere from 2,500 to 3,000 volts.
Wow.
Down the umbilical. And so you have all these transformers that are in oil-filled boxes that are in this depressor. So it's just a nice chunk of weight, and it just stays there and hangs under on the end of the armored cable under the ship. Right. And the vehicle just flies around in a soft tether.
So they're two separate pieces. The depressor is in one place, and then the ROV is separate from that, and it can move around, and the depressor sort of stays in one place. Okay.
And the soft tether between the ROV and the depressor was about, I think, 300 feet long.
Okay.
And the other thing was, when we were operating that vehicle, we didn't have any acoustic navigation on the vehicle or the depressor.
Okay.
So what we did was we just assumed that the depressor is going to be roughly under the ship. So when we found the spacecraft, the location of where we found it basically came from the ship.
Huh.
Because we didn't have any acoustic tracking on that job.
Just because the depressor would go mostly kind of straight down. You're not towing it anymore, so the cable's going sort of straight down, and that's what you use to get an estimate of the position?
Yeah, and we didn't have we certainly didn't have any navigation on the search vehicle, and that's the search vehicle right there, the Ocean Explorer 6000.
Yeah. You
can see there's two little black areas on it. Those are the two different sets of transducers on the search vehicle. The forward part, the kind of square looking part, that's high frequency, And then the longer rectangular part, that is the low frequency transducers.
That one. Wow, I am bad at drawing circles today, but y'all see what I mean, right?
Yeah,
There's
I mean,
one in the front and one here.
Yes, it's a dual frequency sonar, and it was it was really a good that sonar found a lot of shipwrecks.
Kurt,
You had a lot of spots that were pinpointed on your plot there too. Did you explore any of the other ones first, or was you thought it was the strongest candidate, so you just happened to find it?
Well, what it came down to is, you know, when you go into a plot of the ocean and we're 90 miles from the nearest land, typically there's not going to be anything there. Unfortunately for us, there were other things there. This was actually about my third time I'd gone to sea to look for this spacecraft, and during one of the times we went out before, we were using a towed sonar, and I can't remember what the name of it was. And we found a target that we thought might be the spacecraft, but it turned out to be the wing from a crashed airplane.
Really?
So, yeah, in all the places in the middle of the ocean, somebody crashed a twin-engine Piper aircraft right in the middle of our search area, which is not good because you don't want anything else to be down there.
Yeah, yeah.
Now, of all these contacts, some of them are probably aircraft records, but a lot of them are just geology, little parts of the bottom where the mud's really compressed, or there might be some rocks, and it just reflects the sound a little bit. But when we were all done with the search, we had like 88 separate sonar contacts, and we kind of got the contact sheets out, and we all kind of sat around and had like a powwow, looked at the targets, and we evaluated them as a group. And we got those 88 contacts down to like about 15 that we thought were worthy of further investigation. And they were just kind of sprinkled throughout, you know, the search area. So when it came to the point when we were done with the search and we had to decide where to start diving, I looked at the sprinkling of targets, and I said, well, if we're going to look at all those 15 targets, it's going to take us 3 dives, because we're going to have to dive in as one group, then dive in another group, then dive in the third group. And each time you do a dive, well, that's 8 hours just going up and down. So that's going to burn up 24 hours.
Wow. And
so what I did was I looked at the group. There was a group of about 5 targets that were sort of roughly around my best estimate of where I thought the spacecraft was. And they were kind of shaped in a U pattern. And the first target, the farthest one in the north, was target 71, and that ended up being the spacecraft.
Wait, so
it was the first?
Really lucky. That was your first one.
Yeah. What's really bizarre about it is we were down there, and at this point, you know, I honestly I had little faith that we were going to be successful, because we had a lot of problems with the search vehicle that burned up a lot of time. We had bad weather coming in, and so it was just like, okay, we're just going to go down there and you know, do what we can. And we went down, and we're kind of driving around the bottom, and there's all these sand. See, this area is not flat. It has these sand waves in it.
Thank you.
And some of them are quite tall. I mean, like 25, 30 feet tall. And if the spacecraft had landed down in between some of those sand waves, you know, it wouldn't be all that visible on the sonar. But as you can see, it landed on a high point, and we were down there looking around, and all we had seen was like a rusty piece of pipe.
Right.
And the guy who was the project manager for Oceanarium was like, well, you know, okay, there's nothing here. But I got a good friend, a guy named Mark Wilson, and he said, well, you know, let's just move the ship to the west about 50 meters and just do a little more searching, because what we would do is move 50 meters, and then we would search in this 300-foot radius circle around underneath the ship. So we did that, and looking around, we got the scanning sonar going, and he goes, oh, I got some small contacts up ahead. And so we started heading that way, and it was very difficult for the vehicle to move because we had the tether was very tight, and we didn't want to move the ship again. So we're moving up to the north, and we start seeing these little bits of debris, and we didn't really know what it was. It just looked like, they weren't rocks. They looked, to me, they looked like pieces of ice, which of course I knew they weren't, but they just were some identifiable stuff. and I could see actually marks in the sediment where they had rolled down this hill.
Hmm.
And yeah, that's one of them right there.
Is that one of them?
Yeah, you look behind it, you can see where it's actually
Yeah, like
rolled
right
over
here, up this way, right?
yeah, it is over the years. It
Yeah.
is rolled down the hill like a snowball. And so we get up in that area, and then Mark's like, "Hey, I got something bigger up, up behind this stuff." So we just slowly make our way up there, and just, there it was. It was
Just there it was.
I mean, I wasn't, when I first saw that shape on the video, I originally thought, well, I thought it was aircraft wreckage, maybe part of the airplane that's sticking up off the bottom.
Right.
But when we got closer, I mean, we had this big, powerful HMI lights on the vehicle, and they just lit up the words that just said the United States. And I'm like, holy shit. I can't believe it. This is it.
That's that other image, isn't it?
Yeah.
Oh my gosh.
What's the visibility here? Like, how far can you actually see in the water?
Oh, at that depth, under those conditions, we could see easily 50 or 60 feet.
Okay. All
maybe
right.
even more. I mean, when you get down on deep water and you got a good camera and you've got enough lights, you can see pretty far.
Okay.
Now, of course, the objects that we had seen before we found the spacecraft ended up that they were pieces of the beryllium heat shield that was at the bottom of the spacecraft.
Yeah.
And that's what that whole pile of white stuff that looks like salt or whatever, that is actually the decomposed beryllium heat shield.
Really?
Yeah. But the way it worked was when NASA first started out with Project Mercury and they were trying to think about ways to protect the spacecraft during reentry, their original idea was using was called a beryllium heat sink.
Right.
This thing is big and expensive. It weighs like 360 pounds. It's made out of pure beryllium. But then on a parallel course, they said, well, let's look at these ablative heat shields. So they're working on the fiberglass ablative heat shields and are also working on the heat sink. Well, for the orbital flights, they ultimately ended up using the ablative heat shields because they would just kind of vaporize and burn off. But they had all these really expensive beryllium heat shields made, and they said, well, we'll use them on the suborbital flights. So both Shepard's flight and Grissom's flight use these beryllium heat shields. And if you look at that other picture, the one that was just up, you can see the recovery line. Yeah, right there by the T in Liberty Bell 7.
Right.
That line coming down is actually the recovery line that had gone to Jim Lewis's helicopter.
And that's the line they cut, right? To cut the
No, they
the
didn't. They didn't cut it. They had a mechanical release in the bottom of the helicopter, and they released it. But that is actually a stainless steel wire rope that goes up to the top of the spacecraft, and there was still a big like a shepherd's hook on the top of the spacecraft.
Okay.
But that was the line, and fortunately, when we recovered the spacecraft, the line came up with it. And I was a little concerned about that because the loop that line attached to was just it was made of Dacron. It wasn't even metal. And I wasn't sure how strong that would be after 38 years, but it all came up together.
So did you attach to the capsule using the same I'll say attach point that line was attached to?
No.
Or did you have to come up with another way to grasp the capsule? How did you get it up?
What I did was, there's a picture in there somewhere of the capsule being lifted up by the launch on the launch pad. There's a part of the capsule structure. There's this big ring on the end,
right?
And it's sort of cross-sectionally. It probably looks like a piece of I-beam. Okay, if you look at that picture, you see this white structure on the top, and that's what they're using to lift the spacecraft.
Right.
At this point in time, if it was fully fueled and had all its consumables on board, the spacecraft would weigh about a little over 4,000 pounds. Well, that white structure there is attached to the escape tower retaining ring.
Mm-hmm.
And that was the escape system for the Mercury spacecraft. And I knew from research that if that escape tower fired, the spacecraft would be accelerated at 20 Gs, which is a lot. So it was clear to me, especially after looking at some blueprints of the spacecraft, that ring was very, very securely attached to the spacecraft structure.
Right.
So I said, well, that's where we should lift it from. And I had a bunch of other ideas I thought about, but then discarded. But what I did was I developed some special attachment tools that clamped on that ring, and they had like a T handle on them, and
Yeah.
we just attached those 3 tools to that ring, and then we had I think it was like a wire rope bridle, and that's how we lifted the spacecraft. We lifted it up the same way that they're doing right now, actually.
Yeah, or the launch escape system would have pulled the capsule off the top. Kevin, could we get the launch photo that shows it taking off in a second here? Because I hadn't thought of that, and it makes perfect sense. That ring at the top. Yeah, there you go.
Yeah.
This tower on top of the spacecraft, if something goes wrong, that has motors up in the top that fire, and it'll just literally yank the spacecraft off the top of the rocket.
Right. Yeah, there's like a large ring that attaches the capsule to the booster, and in an abort scenario, there's 3 Morton Thiokol rocket motors up there. They would fire and basically pull the spacecraft away from the booster. Yeah.
Yeah.
And take it up high enough. And then the escape tower they have an escape tower jettison rocket that would fire, and then the parachutes to come out, and it comes down, and everybody's happy, I suppose.
Yep. But that's
Makes a lot of sense. But at the same time, though, too, it had been down there for decades
30,
at this point,
almost 40 years.
Were you at all concerned that just the metal itself might be too brittle or it might break there? Like, did it affect your recovery plan at all?
Not once I found out what the spacecraft was made of. Can you see me? I guess you can still see me well.
Yeah, we can see you. Yeah.
This is part of the pressure vessel of a Mercury spacecraft. This is from the. You can't probably see it very well, but there's little lines over there. It's actually it's 2 pieces of very thin metal that have been fusion welded together, and this is actually pure titanium. And it's 2 pieces of titanium. You can see there's 2 pieces. One side has these little panelets stepped in it, pressed in them, and the other side is flat. Well, this stuff is really thin. It's like beer can thickness,
right?
But it's titanium, and titanium handles corrosion extremely well.
Right.
In fact, you really couldn't think of a better material to make the spacecraft out of if you were going to leave it underwater for 40 years.
Yeah.
So once I discovered more about how the spacecraft was made, what materials were used, that gave me a lot more confidence that it was going to be strong enough to be recovered.
Yeah. Gosh, and I think we have a photo of that with this was a Discovery Channel thing, like mandatory credit, it says on the bottom real big. Books out, by the way, I would like you to know too, but that is it coming out of the water, I guess, huh?
Yeah, that was at about 2:30 in the morning, I think.
Yep.
And the other thing about these particular flights, or Mercury flights, was that if you look at the top of the spacecraft, the cylindrical part, that's called the recovery compartment.
Okay.
That is covered with panels of aluminum. In the orbital flights, those panels were made of beryllium because they handled the heat better. But for the suborbital flights, those were aluminum. And the white stuff around the recovery compartment, that's all just corrosion.
That's the aluminum. Yeah,
from dissimilar metals. That's the aluminum corroding, and that because of galvanic action between the aluminum and the titanium. And you can see the recovery tools on top. We actually had 4, but we ended up only using 3 of them.
Okay.
And you can see there's little T handles on them, and there's like lifting points on them. And
the T handle, like in red there, the T handle. That's one you didn't use.
No, that's those go to the shackles that we use to attach the lift line to the tools.
I see.
We call those T-handled shackles.
Okay.
And we use a lot of those things during the Challenger salvage. But you can see there's 3 tools on there, and they look like upside down vices. You put them on there, and you turn the T handle that sticks out of the side of the thing, and it just clamps on it like a vice. And before we actually did the mission, the search and recovery mission, I went down to the Poly Garber facility in Silver Hill, Maryland, and they pulled the Mercury spacecraft out of a crate for me. And I took a lot of photographs of that ring, and actually made up a drawing showing exactly where those clamps should be attached, because you couldn't just put them anywhere. You had to put them in very specific areas because there were places on that ring where there were fasteners sticking out and sensors and things like that. So yeah, there you go. Those are the
Those are the
clamps.
3 clamps, aren't they?
Yeah. But like I said, they had to be put in very certain areas. And when we were attaching those recovery tools to the capsule, I was literally standing behind Steve Wright and saying, okay, put it here, move it a little bit this way, a little bit that way, because they had to be in the right spot. Otherwise, they wouldn't close properly because there would be interference.
This is a silly question. Who was tightening the T-handles? The ROV? There wasn't a person down there, right?
No, it was the ROV.
It was the ROV with the little robotic manipulator?
Yeah.
3 miles below you?
Remote.
Yeah. We held the T-handle, the tool, and the gripper on the manipulator, and he would put it on the ring, and it was open at this time, and I would say, okay, he would just back up a little bit, and I would allow the forest jaw to kind of like catch on the retaining ring, and then we would just sit there, and just rotate the T-handle, and it would eventually tighten up the clamp and give it a few wiggles and tighten it up some more to make sure it's tight.
You can see it in this image again. I mean, there's one of the clamps, like an upside down vise, like you said. It looks like what looks like my drill press vise, honestly.
Yeah, those were made by a machine shop in I think it was Morgan City, Louisiana.
Yeah. Wow.
Was it entirely like you clamped it on, and then was it entirely just kind of lifted, or did you use any sort of like air cushion under it?
No.
When we went to the neutral buoyancy lab, they talked to us a lot about how they use like air cushions,
airbags,
airbags to lift the pieces that are in the big pool there. Did you use any sort of like flotation thing like that to lift it?
No, see that at that water depth, that's really not practical because of the pressure. The ambient pressure at that depth is
that makes sense. It would expand, yeah.
I think it's like 7,000 psi, something like that. So any type of flotation, air-based flotation is just not practical.
Not practical, yeah.
So you just have to basically pull the thing up. And what else is in this picture? Let me see.
Lots of cool stuff in this picture.
Yeah, a lot of corroded stuff.
These look like zip ties.
When you lifted it, did you find that any little creatures had like made a home inside of it? Or
there was a sea anemone in that one picture.
Yeah, there were some anemones around the outside, some soft organisms, but nothing, major.
Yeah.
There's probably
corals growing on it, or like barnacles, or was that all that stuff outside of it mainly just that kind of heat shield?
No, you don't see. You don't really get barnacles at that water depth. Once you get beyond a couple hundred feet, you don't get any kind of barnacle growth.
Yeah. Alicia, all of these little bubbly things, that's what at Starbase, when I have an aluminum bracket and I put a stainless steel screw into it and then I leave it on the beach for 2 years, that's what all of our connections look like because of the dissemination, the galvanic corrosion or whatever it's called. That's worse because that's like growing out, but that's sort of what it is, right, Kurt?
That's exactly what it is. It's just corrosion. In fact, if you hang on for a second, let me go get something.
Oh, sure. folks,
his prop is cooler than my prop. I have a little Mercury capsule. He has an actual piece of a Mercury capsule.
Drop it in your bathtub for about 30 years and put some sea salt in there and see how that little capsule comes out. Folks, thank you so much for watching this show. Like, this is what we are talking about when we say we want to get folks who have done these things on the show and just let them tell us about their experiences. Right. Okay, he's back. Kurt.
And when you look at the outside of that spacecraft, right, these are pieces of the corrosion that were on the spacecraft when we recovered it.
Oh wow, you saved them. That's so cool.
Yeah, don't ask me why. I don't know why.
Because that's awesome. That's why.
Amazing.
Because when it was on deck and we hit it with a fresh water hose and washed all the stuff off, it was all laying around the deck, and it
was like clumps.
I guess I really wanted to preserve every memory of this event, and so I grabbed them up and I think I put them in some sort of a Tupperware container, filled them with water, and then these have been sitting in distilled water for 25 years, I guess.
And I know in your book you also mentioned that you took that recovery wire, the original one from 1961, and you said the helicopter pilot was there with you, right? And you handed it to him and you said, "Here's the other end of your helicopter."
The other end of your helicopter.
Yeah, and I was like, "Hey, yeah, you lost something.
You lost this."
But there you can see. we had procedures in place as well to deal with that beryllium heat shield, because beryllium powder is you don't want to get around it. You definitely don't want to get it in your lungs. It's very
Right.
caustic.
Right.
So I had a whole procedure in place for how to deal with that. But fortunately, by the time the capsule came up, all of the heat shield was basically disintegrated.
Right.
So what you're seeing right there is the fabric from the impact landing bag, and also the stainless steel straps that went around the landing bag.
That's on the bottom.
Yeah,
Like
and
down
also,
this area.
Well, it's on the bottom of the spacecraft below where you see the mud is. That's mud sediment from the bottom.
Right. Right.
And to the left of where it says United States, you can see the periscope flap is still open and the periscope is still extended, like it would have been
Yeah.
when he landed in 1961.
There's that. And then this is the periscope on the side, right? I
Right.
think. Yeah, okay.
Right.
Sorry, I was drawing with the wrong pen. I drew it so I could see it, but y'all couldn't see it. Wow.
What did that feel like to see that emerging from the ocean there? Like, was everyone on board like, oh my God, how did we do this?
I mean, everybody kind of knew how we did it, but
I love it.
we were just all
Did it.
tired. And I remember at one point in time when we were talking about the timing of the recovery, the guy who was in charge of the documentary film said, "Hey, look, we really want to do this in the daytime. This is like the money shot." And I'm like, "Look, I got the head of the CEO of the Discovery Channel saying we cover it as soon as you can." And I thought, okay, so that's what we were going to do. And it just worked out that it was about 2:30 in the morning when we got pulled the spacecraft up. And it actually, I think it made a better image, because it kind of had this surreal quality to it. Like, it didn't look real because it was in the middle of the ocean and we're in the dark. And we got this thing being hauled out of the water that no one's seen for almost 4 decades. And
wow.
And my biggest concern was when we were pulling it out of the water was the weight of the water inside the spacecraft, because it was not insignificant, and I was concerned, that just something might let loose. I mean, but so we lifted it out very slowly and allowed as much of the water to drain as possible before we brought it on the ship. And then once we got the spacecraft onto the ship, then we had another safety hazard to deal with, because there were pyrotechnics on the spacecraft. They had to be removed. In particular, there was a device called the SOFAR bomb, which was identical to the one that was thrown out at main parachute deployment. But there was a second one that was actually permanently attached to the capsule. And that was there so that according to NASA, if the spacecraft sank to a non-recoverable depth, it would detonate. I think at a depth of about 3,000 feet. I think it armed at 2,500 and it was supposed to go off at 3,000.
Right.
But it was a dud for whatever reason.
So they probably thought that it had exploded too. That's probably also why they were like, whatever, we'll just like leave it.
Well, let's see, that's the thing. That's the thing, is that when you look through the post-flight report, they make a mention of the fact that the first SOFAR bomb was jettisoned as it should have been, and that explosion was detected. But then they also say no signal was received from the second SOFAR bomb. So that means that either they didn't hear it for some reason or it didn't go off. And I talked to guys at the Air Force missile test range. It was part of the missile impact locating system. And he told me that about 10% of these things were duds.
Wow.
Which is good, because that SOFAR bomb had 11 ounces of HBX in it, which is like plastic explosive. It would have just blown big hole in the side of the spacecraft.
Wow.
So when we first found the spacecraft on Havana, there was no question in my mind that it had not gone off. And we actually had 2 guys on board the ship whose only job was to find the SOFAR bomb and remove it and dispose of it. That was a guy named Hugh Cease and his partner Buddy Earns from a company called UXB International. And once we had the spacecraft on deck, everybody had to leave, because he had to go in there with a flashlight and look for this bomb. And he found it, and we chucked it over the side off the stern of the ship.
You chucked it over the side.
Yeah, well, what are you going to
Well,
do with it?
What are you going to do with it?
You're
Yeah.
not going to disarm it.
I want it on the boat.
I mean, if it goes off, it's like 20 hand grenades.
Yeah, you don't cut the red wire, the blue wire. You just throw it off the ship. Like, get rid of it.
Throw it away. And
Wow.
beyond that, the other pyrotechnics, there were lots of, God, what do they call them now? These special cutters. There were small pyrotechnic devices on Grissom's personal parachute
Right.
that was inside the spacecraft. See, Grissom, besides all the other escape devices he also had his own parachute inside the spacecraft, right by his left arm, so that if for some reason he had to, he could blow the hatch, put on the parachute, and actually bail out of the spacecraft.
Right.
Well, there were reefing line cutters. That's what they were, and the reefing lines made it so when the parachute first opened, it didn't open all the way, just partially.
Right.
And then the reefing line cutters would fire, and then the parachute would fully inflate. But those were on that parachute, and we had to remove them, and that was what Buddy did. And when they were doing the restoration, they literally just took the parachute to the local fire department. They rinsed it off with fresh water, let it dry, and then they had it repacked by a parachute rigger, and they put it back in the spacecraft.
Huh.
Oh.
Yeah,
So that was for the restoration process, you mean then?
Mhm.
So for those of you who don't know, it's currently now been restored. They took it apart. I think there were like 25,000 parts or something. They took it apart piece by piece to clean it up and everything. And it's currently now on display at the Cosmosphere in Hutchinson, Kansas.
They completed the restoration a long time ago. And they actually did it in front of a webcam, which is kind of cool because you could sit there and get on the internet.
Nice.
And actually watch them working on the spacecraft.
I like that.
Is there anything that you feel like now that people can actually go and see what you salvaged, is there anything on it that you want people to notice, or like some detail that you're really proud of, or something that you want them to notice about what you achieved here?
I don't know. Not really. I mean, it'd be nice if they had my name there somewhere. They used to. I don't know if they do anymore.
When they took it apart though, then, so the hatch story, right? That's like the big thing that everyone wants to know. Did they figure out definitively what happened there, or have any sort of better conclusions as to what happened, how it malfunctioned?
Yeah, there have been some. There's a good theory that was advanced by Andy Saunders and George Leopold, and the only I mean, from looking at the circumstances of the hatch coming off, there's only certain things you can say actually happened. Grissom, after he had landed in the spacecraft, he freely admitted, he said, "Look, I pulled off the cover off the escape power plunger mechanism. I pulled the safety pin, and I just sat there waiting for the call from the helicopter."
Right.
And part of the reason this spacecraft was lost is that NASA had not really clearly defined the post-landing procedures. In other words, when Grissom landed in the spacecraft, once he landed, he really wasn't sure what he was supposed to do. So he did what he thought he should do. He said, "Well, I'm going to get ready to blow the hatch." So he pulled off this cover and pulled the safety pin out, and by his account, was sitting there when the hatch just blew off on its own accord. Well, Andy Saunders and George Leopold, they did a really deep, really detailed examination of the film footage from after the landing when the helicopters were all around it. And I think the best theory of what happened is that there was a static electric discharge from the helicopter to the spacecraft, which triggered the hatch.
Right.
It's common knowledge that helicopters develop a static potential when they're hovering. And, the conditions were good for static electricity. It was warm, there was high humidity. And the other thing was that the way that explosive hatch mechanism worked is there were two percussion caps, just very similar to what you would find like on the back of a bullet cartridge case. And there were two percussion caps. And after Grissom had removed the knurled cover and pulled the safety pin out, if he hit that plunger, it cleared a path for two firing pins, which would hit the percussion caps and set off the explosive around the perimeter of the hatch and blow it off. Well, he never hit the plunger. He says he didn't. He didn't have any bruises or anything on his hand.
Yep.
The thing about those percussion caps is, if they're like most percussion caps, they have some very sensitive chemicals in there. In particular, mercury fulminate,
Right.
which is what makes the percussion cap fire in the first place when it gets hit by something. But mercury fulminate is very sensitive to static electricity.
Right.
And so I think the best theory of what happened was that when John Reinhardt, the co-pilot of the helicopter, touched the top of that spacecraft with his recovery hook, he said later on that he remembers seeing an arc.
Right.
And I think that actually set off only one of the percussion caps had to fire, set off the percussion cap, blew the hatch, and that's what happened.
Yeah.
That's and people say, well, gee, why didn't that happen on any of the other flights? Well, Shepard's mission didn't have an explosive recovery hatch. And on all of the other Mercury missions, they never used a helicopter to recover the spacecraft. And they never blew the hatch in the water. They would literally maneuver the ship alongside the capsule and lift it out of the water with a davit.
Right.
So once that happened, there was
Aircraft
never
carriers. Like Intrepid.
Like Intrepid aircraft carriers, yeah.
Yeah, there was never an opportunity for that situation to happen again.
Yeah.
So I think that's the most logical explanation.
It's similar to like electrical potential differences between a flying object and the ground. That's similar to the theory of how the Hindenburg went up. Like a difference in potential coming down a line to more so that there's a spark that sets off as those electrical potentials even out. Same sort of thing, like flying things can generate differences, not like lightning, it's not the same sort of thing, but they can generate a difference, and then when you ground it out to the spacecraft or the ground or whatever, that difference happens and you get an arc or a spark or something like that could absolutely cause something
everybody
like that.
knows that helicopters have a static potential that it has to be discharged before you touch them.
Yep.
And yeah, I've read that story about the Hindenburg, that the recovery lines that the handlers on the ground were touching were soaked with water and conducted potential.
Yep.
And that's likely what caused the Hindenburg to go down.
Yep. It's just a thing. It's of the many tiny things that you have to think about when doing any sort of operation. Just with this or anything, it's like these little things can get you, and that might have been what happened. Hey, Kurt, can we show a couple pictures that we don't know what they are? And have you explain what these photos are? Kevin, go to town. Yeah. What is this?
That's the SOFAR bomb that they removed from Liberty Bell 7. And the arming mechanism is right by that, I guess, Buddy's finger.
Yeah.
And you can see on the side of it, there's like a kind of a black and white oval shaped label that says Vermite, I think.
Right.
And that's the company that manufactured these things. And they were out in I don't know, Nevada or someplace like that. But that device has 11 ounces of HPX in it, which is the high explosives. And it was a mechanical mechanism that set it off. I think, let's see, there was a plunger in there and the water pressure would break one pin and then the plunger would move in and create a path for another plunger. Then when it went a little bit deeper, then that one would fire and set the thing off. But fortunately, it never went off. But that's the SOFAR bomb, and that's now somewhere on the bottom of the ocean.
Back at the bottom of the ocean. If somebody wants to recover it in another 30 years, they can go look for it. Y'all just tossed it off the ship. What is this?
This is the interior of the spacecraft as it looked after we recovered it.
Yeah, it looks like labels on switches or something I sort of see in there.
Yeah, that's actually I think that's a circuit breaker panel.
Yeah. And that would make sense.
I mean, it's kind of hard if the photograph wasn't so zoomed in, it would be easier to tell what's what. But you can see the lower edge of the hatch sill. There's a wiring bundle in the lower right.
Maybe.
And
it's a bundle.
Yeah, I think that thing there is the well, no, wait, I take that back. That isn't the circuit breaker panel.
Yeah.
That's just a place of a bunch of lighted up
indicators
switches
or something. Yeah,
and you can also, I think you can see some circuit breakers in there underneath this kind of green looking wiring bundle. But that's just a picture of the interior of the spacecraft, and that's the only problem I had with the rest. I mean, I had a couple of minor issues with the restoration and that. Okay, and in this picture you can see they've reassembled the optical periscope. That's that circular screen in the middle.
Yep.
You can see the aluminum forward exit hatch in the very top of the picture.
Yep, that's up there.
Yeah, that's what you see me removing.
You were removing that. Yeah,
Yeah.
in that other picture.
Because what had happened is it had fallen out of place and it was wedged in the open hatch
Ah,
opening.
okay.
On the lower left, you can see those are the circuit breaker panels.
Way.
What I didn't like is if you see the green kind of plexiglass looking thing there on the right, yeah, that's part of the control panel that they replicated during the restoration. And I didn't like the fact that they'd used plexiglass. I thought they should have just made it look like it was supposed to look like, but
Oh.
that's just my opinion. And like if you look at, there's a control joystick, uh, so like sort of in the bottom center.
Yep.
They made that out of plexiglass.
That's right
And
there.
again, I feel like they should have tried to make it look the way it originally looked.
Yeah. That's weird.
on-
I don't know why it's clear. It looks weird.
Yeah, it's not supposed to be clear. And if you look on the left, in the lower left corner, underneath that circuit breaker panel, there is it's like his emergency rescue kit or something. And
that down there.
yeah, that's where the
Yeah.
parachute was, over in that area.
Wow.
And
I don't know. Like, why would they make this like a clear plastic if it was originally a solid metal panel or something like that?
yeah, it was
Like, you
originally
spine
aluminum.
it?
I don't know. I think their logic was they wanted people to know that was not original.
Was redone. Yeah. Like,
yeah, and I'm like, well, just make it look the way it's supposed to look.
yeah, I guess I get it. Like, this part wasn't recovered, so we put in a placeholder to know that it was there, but this isn't something that was recovered. It was a model that
Yeah,
we made or what.
yeah.
It looks funny.
Yeah, I know.
Yeah. Okay. Huh.
But they did a good job. I mean, it was an incredible amount of work to do what they did, and I think most of it was actually done by volunteers.
Yeah. Where is this now? This is in a Cosmosphere, I think?
Cosmosphere.
Yeah, Kansas
Cosmosphere.
Cosmosphere and Space Center in Hutchinson, Kansas.
Yeah. Excellent. Here is a map or chart or something in a bound.
Yeah, that is actually. I'm going to turn on this light in here.
Okay. We're going to turn on the light real quick. Again, we have a folder of, what do you think, Alicia? Like 30 or
gosh.
40 or 50 pictures that Kurt sent for the show.
All right, is that better?
You're good.
I want to show you something. Yeah, that is his orbital. It's like an orbital chart. It's basically a map of the surface of the Earth, so that if he needed, I guess, to figure out where the heck he was, he could look at this map.
I assume that's not made out of paper. That must be some sort of laminated
like
something or other, right?
Coated something, or yeah.
I'm not really sure. Yeah, it might have been some kind of plastic. And the reason I'm going to talk about that is
because I have it right here.
Because I have a piece right here.
Well, no. Well, one of the things that we recovered from the spacecraft was Grissom's post-flight checklist.
Right.
And what that is basically a piece of clear plastic, and inside of it was some paper which had different things written on it, and he would go through his checklist and hit him with a grease pencil.
Yeah.
Well, when we pulled when the checklist, post-flight checklist was originally pulled from the spacecraft, it was legible. You could see the grease pencil marks from it and everything, and they just put it in water and left it. Unfortunately, when they pulled it out of the water, the paper just turned black from the acid in the paper. And this is what is left of Grissom's post-flight checklist.
Wow.
And you can see this black stuff right here is actually it's what's left of the paper.
Yep.
And I don't know why this has a circular thing here, but there's basically some looks like almost like duct tape over here. And you can see some holes here from where it was put into a binder or something. Yep. But what they should have done was consulted with somebody who was an expert in document analysis or document preservation.
Right.
But anyway, this is what happened. And the reason I have it is because after this happened, I had some friends who worked at the FBI laboratory, and I said, well, let's send it to them and see if they can do anything with it. And they basically did a bunch of tests, said, no, nothing we can do with it. It's
nothing
gone.
We can do with it. We can't, like put a piece of paper and scribble the pencil to get the handwriting on the hotel pad.
Yeah, one of the things I was looking for was actually a recreation of his post-flight checklist, because somewhere I do have a photograph of that checklist as it looked when we pulled it from the spacecraft. And that's where you can actually read the procedures, and you could see his grease pencil marks. But unfortunately, all that's gone now.
Yeah. Wow. That makes a ton of sense. Like you're pulling this thing out of the water and you're changing the environment that it's in.
Right.
It's been in the ocean water for this amount of time, and then you take it out and you expose it to air, oxygen, whatever you want to call it. You could have, if there was an expert who knew how to handle it, they could have kept it in salt water to keep the air away from it or whatever. You know what I mean?
Well, that's the thing. And the main thing is
Yeah.
it wasn't in the open air. There was no oxygen, so
Yep.
it was underwater, and so they took it out of the water. This is the explosive. This is the cover for the explosive hatch igniter,
Right.
and I found that inside the spacecraft, down in the footwell or something like that. And if you go
Wow.
back to the picture before with a knife,
Oh yeah, what was the
Yeah,
knife?
that's-
Made in
that's-
Florida, it looks like.
yeah, or that's who made those knives?
It says Randall, I think, or
Oh,
Crandall.
that's right, Randall Knives, Orlando, Florida. This was custom made for the Project Mercury. I think it was Scott Carpenter who arranged all that. But you can see
Wow.
when they put this capsule on tour, one of the things they did was they removed that little loop, or the black lanyard. They removed that, and I'm like, I don't understand why they did that, because that's what makes this knife unique. Because the reason that coiled lanyard was there was so that the astronaut could attach it to his spacesuit, and in 0G it wouldn't float away. But for some reason, when they put the knife on display, they took that away.
They took it away. It's like, oh, it's a knife. It doesn't have a phone cord on it or whatever. Like, no, it's not a phone cord. It's a retention device.
Right.
For spacesuits.
But it came out pretty well when I found it. It was sort of like down on the footwell where the hatch igniter cover was, and it was just all gunked up. But it cleaned up pretty nice.
Yep. Wow. Very cool. Kevin, do we have any other? Oh, we got more here. This is it being shipped.
Yeah, that's the container. That container was specially made by the Superior Boiler Works near Hutchinson, Kansas, and that was specifically made to hold the spacecraft. And
Does it have water in it?
Yeah, it did.
It's got valves on it.
Yeah, it did. It did fill. We did fill it with water. What we did was we took the area. The bottom part of this container was nearby where we recovered the spacecraft.
Right.
And after the spacecraft was recovered, we didn't want to leave it on deck for too long because we wanted to get it out of the air. Mm-hmm. So we actually lifted the spacecraft up and put it in this container on the deck of the ship, and then put the top on the container, which, believe me, was not an easy thing to do at sea on a ship. And we filled it up with fresh water, and we let it sit in the fresh water. When we got back to Port Canaveral, we drained the water out, and then we took the top off just so people could see the spacecraft. And then they put the top back on, filled it back up with water, put it on a flatbed truck, and they took it to Kansas. Now, the way this worked out from the legal standpoint, the legal issue of who owned this spacecraft was kind of it was something that had to be dealt with. You're never going to get away without dealing with lawyers somehow. When the spacecraft was on the bottom of the ocean, it belonged to the United States government. It was built by funds that were appropriated by Congress, so it belonged to the U.S. government. Could we have made a case that if we salvaged it, it belonged to us? Yeah, but the government's got nothing but lawyers that sit around and litigate stuff forever. So what I did was I worked with the NASA's Office of the General Counsel, and I negotiated an agreement whereby if we found the spacecraft and we covered it, that they would transfer ownership to the museum. So the way it worked was, I think, when the spacecraft hit the deck of the recovery ship, for a brief period of time, the Discovery Channel owned the spacecraft. And then
really?
When it was taken off the ship and put on the truck to go to Kansas, title transferred to the Kansas Cosmosphere Space Center. So it's the only manned spacecraft in our history that is not owned by the Smithsonian Institution. Because by agreement, all NASA artifacts, once they are accessed by NASA, Smithsonian Institution has the first right of refusal.
Gotcha.
And I actually managed to get the Smithsonian Institution to say, we don't want this spacecraft.
Right. Well, they
And that,
weren't paying for the recovery, were they?
well, it's not just that, but if they were going to own the spaceship, then they'd have to pay to restore it.
Yeah.
And they didn't want to do that. Plus, I don't think they were even certain that it could be recovered or it would be in decent enough condition to be restored. So that was one hurdle I got over a long time ago before the actual expedition. I was dealing with a guy named Derek Elliott at the Air and Space Museum.
Okay.
And so anyway, yeah, the legal stuff had to be worked with, and we had to give, NASA, tell them NASA that, well, somebody got killed there or blown up during the recovery, that it wasn't their fault and all that kind of stuff.
Yeah,
and that the Cosmosphere would agree to restore the spacecraft, take care of it, and display it in a tasteful manner.
Yeah, that makes sense.
Was the Grissom family involved in this at all either? Though, because I would assume maybe this would be an opportunity to clear his name, like the hatch wasn't his fault. What did they think about all this?
Well, Betty Grissom didn't think too much of it.
Yeah.
There was this one AP reporter who kept calling when we were doing the expedition. They would keep calling up Betty Grissom, and Betty Grissom, God rest her soul, she liked to talk to reporters sometimes, and she didn't like the whole thing. In fact, even several of the Mercury astronauts didn't like the idea, in particular Deke Slayton, because they somehow thought that it would raise this whole issue of the hatch being blown off and somehow cast doubt on Grissom's character or something. And that was not what this expedition was ever about. It was about simply finding the spacecraft, recovering it, and restoring it so it could be put on public display.
Yeah.
So
I think they hadn't gotten a really, in my opinion, this is a complete opinion on my part, but they hadn't gotten a really fair shake in some of the portrayals, like astronaut panicking and blowing the hatch. And it's like, yeah, you don't really have any evidence that that's what's happened, but you played it up in these portrayals in the media to try and get people to watch it because it was dramatic that way, right?
Yeah, that Grissom is kind of portrayed like as a buffoon sort of in like the right stuff, and it's like he's all like,
that was all Tom Wolfe, all of that stuff about him and the spacecraft after that was all just total BS. I've listened to the air-to-ground communications many times from this flight, and I've read the transcripts, I've read his post-flight interviews, and it was nothing like that. I mean, you got to realize Grissom was a professional test pilot. He flew 100 combat missions in Korea. He was highly regarded by all of the Mercury astronauts. So to suggest that for some reason he lost his mind or panicked after landing his spacecraft, it's just total nonsense.
Yeah. Wow.
He was actually thought of to be probably the best pilot of all of the Mercury astronauts, and had he not died in the Apollo 1 pad fire, he probably would have been the first man on the moon.
Wow.
This shows the outside of the container with a bunch of signatures on it. Unfortunately,
go ahead.
Well, unfortunately, Cosmosphere left it sitting outside, so all those signatures kind of went away. So, but I have this photograph.
Yeah.
What they did with the spacecraft when it got to the museum was they had a special location. They actually built a restoration facility at the Cosmosphere specifically for this spacecraft. And while they were building that restoration facility, they literally circulated fresh water through that tank, through that container, for like a month or maybe even longer than that. I mean, I think Max Airy told me that 1 month their water bill was $9,000. Wow. So they did that just to wash as much of the corrosion and get all the salt water off the spacecraft, because for it to be a viable long-term artifact, they had to get every bit of corrosion off the structure of the spacecraft.
Stabilize it. Yeah.
Yeah. And then when we were actually doing the restoration, they pulled it out of the container, and they had a special thing. It almost looked like a shower stall, and we put it in there, and it literally just hung in this shower stall with the same recovery tools on it that we used to recover it, because we didn't want to set it on the bottom on its bottom, so it just literally hung in this stall and was pretty constantly just rinsed with fresh water on the exterior.
Wow. It's interesting, like the photo of all the names on the panel there. That's not the spacecraft itself, but that's recovery hardware that was critical to getting the spacecraft back, like the ring that you clamped to the top, right? And I could see somebody at the museum being like, oh yeah, we don't need that, just toss it outside. But especially from your perspective, equipment like that is almost an artifact in and of itself, like documenting your time and the work that you did to get this spacecraft back from the bottom of the ocean, right?
Well, yeah, I mean, it was a lot of work and
Yeah.
took up 14 years of my life. It was no trivial task. I spent a lot of my own money on it,
Yep.
but yeah, I mean, I mean, I don't know exactly what they're displaying in Kansas right now. I mean, obviously the spacecraft is there. You know, the spacecraft went on tour for several years after recovery, even international. I think it was in Germany for a while.
Yeah.
I can't remember if it was in England or not, but it went all over the United States. And really, what I think the best thing is that came out of this, there's a whole generations of people that didn't know anything about Project Mercury,
Right.
didn't know who Gus Grissom was. So I think the publicity that this project generated really educated a lot of people about how our space program started and who these guys were.
Absolutely. I think part of it there is you're not only recovering artifacts. For me, you're sort of making artifacts. Like I would love to see your solution to clamp to the top ring to recover this thing. That's what I want to see in a museum. Okay, cool. That's the spacecraft Elysia. For the museum's underwater recovery exhibit, it would be fantastic if the ring that was used to recover Liberty Bell 7 was one of the things there. That's amazing.
Yeah,
I don't know if
stuff
you're
like
Yeah,
that.
but the ring is part of
Not that.
the ring is part of the spacecraft, though.
Oh, the clamp that you put on it. The
Oh
clamps
yeah, the
and stuff
clamps.
you
Yeah,
put
they
on.
have,
Yeah.
I think they have at least one of those on display in Kansas. I mean, after
Go see
our
it.
first expedition, I had all those clamps sitting in my closet in my bedroom.
Really?
And yeah, and we
Right next to
actually,
the titanium piece of the Mercury capsule,
yeah,
just in his
um,
closet.
yeah, I think they have those in Kansas. And I think when the exhibit was on tour, they had my notebook where I drew the first sketches of the tool and how it would work and that kind of stuff.
Very cool.
But all that stuff, all of my documentation on this project, I gave that to Stafford Air and Space Museum in Weatherford, Oklahoma.
Okay.
So if anybody ever wants to research this project, that's where they got to go.
There you
Why
go.
that particular museum or
Because the guy who was running the Cosmosphere during this project ended up the president of the Stafford Air and Space Museum, and also because Tom Stafford, the Apollo astronaut, was a very big supporter of this project and opened up a lot of doors for me. So
Wow.
I thought it was very fitting that they should have all my records.
Yeah,
That's
gotcha.
amazing. Well, I definitely want to also mention it to everyone that our guest here, Kurt, actually has written a book
Yes.
chronicling all of his amazing tales about his excavations and all of his time just being able to lift all this stuff off the ocean floor. There's some really great stuff in here about Liberty Bell 7, as well as so many other things: the Challenger, the TWA 800 flight, Air India flight 182. So many amazing stories in this if you want to hear more about what he's done, and also just really interesting stuff about your life as well. Anything you want to talk about with the book? Came out last.
It's pretty good. It's pretty good. I mean, the main thing was to, I guess, tell people, what my background was, how I got into this business, and to sort of give an insider's account of some of these recovery operations, because some of them are well known, like TWA Flight 800, maybe the SSL Pharaoh, and stuff like that. But a lot of them aren't, and a lot of them were just run-of-the-mill, deep search and recovery operations. Because the thing is, I primarily worked with the deep water stuff. Shallow water stuff that was usually done by somebody else.
Right.
So that's a piece of wreckage from TWA Flight 800, and that was taken on the USS Grasp in 1996, I guess.
Wow.
That is a fluid container on the SSL Pharaoh, and that's at a depth of, I think it was about 13,000 feet, thereabouts.
Wow.
I don't see that. Oh yeah, 4,725 meters.
Meters, probably. Yeah.
Well, let me see. Yeah, 4,725. So that was, like 15,000 feet, 14,000. So what happened there is that's a fluid container, and that's actually the only shipping container that was still on the El Faro, and it was a fluid container. You can see it's literally been crushed by the water pressure at depth.
Yeah.
And the stuff in the upper left, it says El Faro. That's because that's the project we were working on. Looks like dive number
Dive
2. Curve 21, that's the underwater vehicle, and it says USN, U.S. Navy, SupSalv, Supervisor of Salvage and Diving.
Nice.
And yeah, okay, that's a, make sure now. Is that
Looks
the
like an outline of a ship on the ocean floor, it would be my guess.
Oh yeah, it's definitely a ship. I'm trying to remember which
Yeah.
one it is. I don't think it's the Indianapolis. I'd have to look at my book to be sure, but it could be the Indianapolis. I'm not really, I don't remember.
Yeah, I think it's labeled Indianapolis in the back
Oh.
end here.
Okay, well then that's what it is. That's the
Okay.
USS Indianapolis.
Good deal. If you want
so
to,
many, you're like, oh, I don't know.
it's like I don't know that one. Yeah.
That is a piece of the orbiter, and that photograph was taken on the
Oh wow.
motor vessel Independence. And because when I got done with working on the Standard Workhorse, which was the ship we used to recover the booster wreckage, I went over to the Independence, and we were recovering pieces of the external tank and the orbiter. And that, because that was fairly shallow water, it was only about 80 feet. Okay, that is the forward skirt of the right-hand booster from the Space Shuttle Challenger.
Wow.
And you can see the all these parachutes and stuff draped around the bottom of it. So that's the very forward end of the right-hand solid rocket motor.
Wow.
Okay.
If you had unlimited resources, Kurt, you've done so much already, but if you could do anything else, is there like a white whale for you that you would just love to go and
look for? Yeah.
I kind of already had my white whale.
Which one?
That was Liberty Bell 7.
Ah.
I mean, once I got that done, it's like, I mean, it's, what people forget is that a lot of times it's really not what is technically feasible as far as what limits what you can and can't do underwater. It really, for the most part, it really comes down to money.
Yeah.
Who's going to pay for this stuff? Like, there's been a lot of people out who have like tried to find Amelia Earhart's Lockheed Electra.
Yeah.
It may be found someday, but you try and search in that part of the ocean. It's a long ways. The mobilization costs are expensive, and it's not cheap. And there's only so many people that can afford to do that. Right. And the only reason that the Indianapolis was found is because Paul Allen was willing to pay for it.
Yeah. It's like
go ahead. Well, we really didn't have. I mean, it wasn't really a good location on the ship. I mean, it was. As far as where the Navy said they thought it went down, the actual location of where that ship was found was 30 miles to the west. That's a lot of territory to try and cover in, that kind of water depth, because it's deep out there. And plus the terrain's not terribly good, but it really took a guy like Paul Allen, who was just really liked World War II history and was willing to fund it all. Otherwise, as we're sitting here today, if it hadn't been for him, the Indianapolis would still be unfound.
Yes, still be down there. Wow.
Well, it's
unfound. Yeah, it's still down there. Sorry.
Yeah.
Yeah. Okay.
So, well, what now?
Well, Kurt, we were a few minutes over the time we had allotted for the show today.
Oh.
There's so many interesting questions or so many interesting photos that you had provided. So I think we were just jumping through some of the miscellaneous photos there. But folks, if you're watching, we did put that link to Kurt's book in the chat. If you want to hear more, you can go click on the link. Alicia's got it right there. You can click the link, you can pick it up and read about some of these adventures in recovering these artifacts, finding them, all the stories like we've been hearing here today. But Kurt, this was absolutely fantastic. This is what we try to do with these shows. We're not doing PowerPoint presentations. We're just sitting down and looking at your experiences in your life and seeing the cool things you've done. And then we're looking at, what is that? Is that a camera? Is that a plug? How does that work? It's so interesting to hear that straight from the person who developed some of these solutions and made it happen in the real world. Thank you so much for taking time out of your Sunday to talk with us.
Yeah, I'm surprised I was able to talk this long, but there you go.
Everyone always is, but
Okay.
There's so much to talk about.
It's been a pleasure.
Absolutely. It's not for lack of content, we could say. There's always plenty of content to talk about. It's whether or not we can keep talking for that amount of time, but we never seem to run out of it. folks back at home, please say thanks to Curt Newport here for spending his Sunday evening with us and telling us all these tales of his experiences out there. Check out the book. Click the link over there. Also, folks have been supporting the museum here as well on the show today. I see it's almost like $200 worth of donations to the museum so we can keep doing shows like this for you. RC Horseman, Hawaii Mike, a couple anonymous ones in here, all the names that I saw scrolling through there. Thank you so much for making it so that we can continue to do shows like this. You know, we're not here trying to make profit off this. We're not selling you merch or anything. There's not tens of thousands of people watching ads or anything. We just do this because it should exist. It should be here for people to see. So make your folks watch it at Thanksgiving. Put it on the TV. Make them watch. Just be like, oh, I saw this really cool discussion. Yeah.
I think it's fascinating stuff. But yes, thank you so much for the support. We really appreciate it. And also, of course, you know, the museum also exists. Please come visit the museum in person too, if you can. Bring your family for the holidays. Why not? Hey, yeah, during Thanksgiving, have Thanksgiving in New York City. Hey, but yeah, as I mentioned earlier this summer too, we opened a brand new exhibit in our Space Shuttle Pavilion. There's still time to see it. It's called Mysteries from the Deep: Exploring Underwater Archaeology. It'll be here through January, which again is why we've been featuring so many cool underwater parallels with space topics over the past few months. So the exhibit, as you can see here, it was co-produced by the Intrepid Museum and Flying Fish, and it explores all the different types of work and tools that people just like Curt do to hunt down and salvage some of these really incredible lost things. So it features things like ships and planes, fossils, and even whole lost cities there too. So if you do happen to be in the New York City area in the next couple of months, come by and check it out. It is open through January 11th. And as was just teased there earlier too, don't miss out on our next month episode of Astro Live. We're going to be switching it back up again, leaving the extreme environment of under the sea, and we're going to go back to the extreme environment of space again to talk all about NASA's Dragonfly mission, which is going to send the rotorcraft to explore Saturn's largest moon, Titan, and it's going to be looking for the building blocks of life. I'm super excited about this one. So we're going to be talking with experts from the Johns Hopkins Applied Physics Lab, including the principal investigator for the project as well. So yeah, check it out, intrepidmuseum.org for more information. You can find it on our Eventbrite as well. And tune in here, same bat time, same bat channels to come see that episode.
Nice. I like this. Fred Smith 6342 in chat says, I gave up NFL football to watch you. It was worth it. That's high praise. That's high praise.
That's huge. Oh my gosh, I appreciate that.
That's pretty good. Yeah, I don't watch football at all, actually. But okay.
Oh, there we go. One more time, Curt, thank you so much for spending time here today. We really do appreciate you.
All right, it's time for me to make dinner.
All right, it's time for dinner. And
See
folks,
you guys later.
Take it easy, Curt. Thank you so much. And folks, remember the shows don't just happen. Astro Live supported through a NASA cooperative agreement awarded to the New York Space Grants Consortium. As long as y'all keep showing up and we still keep getting cooperative agreement grants here, we'll keep doing Astro Lives for you once a month with Intrepid Museum. That's going to be the show for today. Thank you so much for watching. Send it to a friend. So many people don't know that we do these shows, or it's not SpaceX launching Starship or something. Oh, I'm not going to click. I'm not going to watch. If you thought this was super interesting, you know another space fan who might think that this is super interesting, send them a link. Let them know. Like I said, put it on the TV and make the family watch it Thanksgiving or something. I don't know. That's coming up. But thank you so much for watching us today. Alicia, thank you so much for joining us. Always a pleasure to have you.
Yeah.
And I will see y'all later. All right, into the show. Thanks for watching, y'all. Take it easy.
And here we go. We have liftoff.
Propulsion continues to be nominal.
R68 chamber pressure looks good.
Following up.
They go down to nominal.
Flight downside FD off. FD off. It's orange! 145! Oh my god! Oh my god! Décollage! What is it? Put that in the big bag,
343 unfolds to go.
Indeed.
We rise together back to the moon and beyond.
The methane will be igniting in the flare, correct?
see it anymore.